Okay, here's a nice integral that we can solve with a trig substitution. So notice we have x squared minus 3 squared, which tells us we probably need to use a secant substitution. So let's get at it. So we should maybe try x equals 3 secant theta, which leaves us with dx equals 3 secant theta tangent theta d theta. And finally, x squared minus 9 will be equal to 9 tangent squared theta using trig identities. Okay, so now we can substitute all of this into the integral and see what we get. So the dx component is going to give us 3 secant theta tangent theta d theta. So that's in the numerator. So we've taken care of this. Now, if x is 3 secant theta, then x squared will be 9 secant squared theta. Good, so that takes care of this bit. And now if x squared minus 9 is 9 tangent squared theta, then we can take the square root of that, and we'll be left with times 3 tangent theta. Okay, so now we can see there's quite a bit of substitution that can go on. So let's do that. So we can have tangent cancel with tangent. We can have this 3 cancel with this 3. And then finally we can have this secant cancel with one of the secants in the denominator. So that's going to leave us with 1 over 9. So we can bring that out front. And then we have 1 over secant theta d theta. Okay, good. But now, using trig identities, we can write this as a more familiar function. So that is cosine theta d theta. Good. And then that's a fairly simple integral, so that'll give us 1 over 9 sine theta plus a constant. Now we may think we're done, but we've got a little bit more to do. We need to write this back in terms of the original variable. So we'll go back over here and see that x equals 3 secant theta. And so we'll take this to write secant theta equals x over 3. And then remember that secant is hypotenuse over adjacent, so that allows us to create a triangle. So that has x at the hypotenuse and 3 at the adjacent, keeping in mind that secant is 1 over cosine. And then the opposite angle, keeping in mind that this is theta, will be the square root of x squared minus 9. And so now we can fill out what sine is. So from this triangle we can see that sine theta is opposite over hypotenuse. In other words, it's 1 over 9, the square root of x squared minus 9 over x plus a constant, and that's our final answer.